Good morning, student. So today we will discuss about the working of petrol engine and working of diesel engine. So if you are considering of the petrol engine, means it is related with the spark ignition engine. So why we are calling the spark ignition engines? Because for igniting the air fuel rate, fuel air ratio, we are using the spark plug, and this spark plug will produce the spark, and due to that spark there will be the combustion or ignition of fuel and air will be occur. So while discussing about the working of petrol engine, so we should know that this is the inlet valve and this is the exhaust valve. So this both valve will be controlled by the rocker arm, then push rods and camshaft, and this camshaft is connected with the crankshaft. So whatever the power produced by the crankshaft, some of the power will supply to the camshaft, and that camshaft will control the opening and closing of the inlet valve and the exhaust valve. So this inlet valve is connected with the inlet manifold. So here there will be the pipe will be there that will connect this inlet valve or this cylinder with the intake system. So that valve, that pipe we are calling the intake manifold. So this is connected with the intake manifold, and this exhaust valve is connected with the exhaust manifold. So here this is the piston, and this piston is connected with this connecting rod, and this connecting rod is connected with the crank, and crank is connected with the crankshaft. So this crank is revolving. So we can easily say that if here there is a bottom dead center, and we can say that somewhere here there will be the top dead center. So these pistons will move from bottom dead center to the top dead center, and whatever the distance will covered by this piston while moving from bottom dead center to the top dead center, that we are calling the stroke. So we can easily logically find out that, so if this piston is moving from bottom dead center to the top dead center, crank will revolve in half revolution. It will cover the half revolution. Means if the top dead center is here, so with reference to this bottom dead center, the crankshaft will be exactly in line at the bottom side. So somewhere here will be there. If it is rotating clockwise, so when it is moving from in this bottom inline position to the upward inline position, so these pistons will move to the top dead center. So while covering the stroke, this crank will revolve in half revolution, and this we are calling the stroke. So this is, so in petrol engine and diesel engine there will be the 4 strokes will be there. When at the starting of the engine, so we can say that this piston is at the top dead center. And it is moving from top dead center to the bottom dead center, and inlet valve will be open. This inlet valve will be open, and piston will move from top dead center to the bottom dead center. Now you just imagine, if this piston is moving, so this valve will open instantaneously. It is opening instantaneously, and this piston is moving from top dead center to the bottom dead center. Means if it is moving from top dead center to the bottom dead center, there will be the suction will be created into the engine cylinder. Now this inlet valve is open, and this system is in line with the surrounding. So surrounding there is a atmospheric pressure is there. So this, as the suction is created in the engine cylinder due to the movement of piston from top dead center to the bottom dead center, the fuel air ratio will be sucked into the engine cylinder, and it will maintain the constant atmospheric pressure inside the cylinder, because as the simultaneous process will be happen, suction will be created, and it will try to maintain the pressure inside the cylinder, so that inlet valve fuel air ratio will be sucked into the cylinder, and likewise it will maintain the atmospheric pressure inside the cylinder. So this process will occur at constant pressure, means we can say that at atmospheric pressure. Suction process will be occur, we can say intake process. Suction process will occur at constant pressure process. It is a constant pressure process, and that constant pressure process is nothing but that constant pressure is atmospheric pressure. Means during the suction process we are maintaining the constant atmospheric pressure. So this piston move from top dead center to the bottom dead center. Now once it is coming at the bottom dead center, inlet valve will be closed. It will be closed. And now this piston, because this piston, as the crank is rotating in clockwise, so this piston will move from bottom dead center to the top dead center. So as this piston is moving from bottom dead center to the top dead center, so this fuel air mixture inside the cylinder, it will compress from BDC to the clearance. So we can say the total cylinder volume to the clearance volume. It will compress to the clearance volume. As it is compressing, its pressure and temperature will be increased, and this compression will carried out isentropically or adiabatically. So at the end of the compression, so this is the second process. Here it is shown over here. So this piston is moving from this bottom dead center to the top dead center. Due to the movement of the piston from bottom dead center to the top dead center, this fuel air mixture, it will compress from total cylinder volume to the clearance volume. It will compress from total cylinder volume to the clearance volume, and due to the compression, temperature and pressure of the air fuel mixture will be increased. So at the end of this, now this both valve are closed. Now you can see that this inlet valve is closed and exhaust valve is closed. So at the end of the compression stroke, this spark plug will produce the spark. It will produce the spark, and due to the production of the spark, so what will happen? There will be the burning of fuel will be occurring. As the burning of fuel is occurring, it will liberate the heat. It will liberate the heat. As the heat energy is liberating, there will be the pressure will be created in the combustion chamber. So due to the pressure, it will apply forces over the piston surface, piston face area. So due to the forces, the piston will move from top dead center to the bottom dead center, and there will be the production of work will be happen, and these forces we are converting into the shaft power. We are converting into the shaft power, and so this is the power stroke. This stroke is the nothing but the power stroke or expansion stroke. This is the expansion stroke. So this piston will move from TDC to again BDC. Now at the BDC, now this piston is at the BDC, and at the BDC then exhaust valve will open instantaneously. As the exhaust valve is opening, this piston will remain at the BDC. The piston will remain at BDC, and as the exhaust valve is opening, so heat inside the cylinder will exhaust it to the atmosphere, and this will occur at constant volume. It will occur at constant volume. So heat rejection is occurring at constant volume. Similarly, in the compression in the combustion stroke, so heat generation also will occur at constant volume process. Means it will maintain the clearance volume inside the combustion chamber, and constant volume heat addition will be occur, and constant volume heat rejection will be occurring during the exhaust stroke. During the initiation of the exhaust stroke, means when the piston is at bottom dead center, at that time there will be the sudden heat transfer will be occur from the cylinder to the exhaust valve, and after that this piston will move from bottom dead center to the top dead center. During that process, due to the movement of this byproduct of combustion it will get exhausted, it will get expelled from the cylinder to the outside, and some of the portion of the byproduct will be remain in the clearance volume. So we can think that there are the 5 event will be occur during 4 strokes. So this is the first stroke, this is the second stroke, third stroke, and fourth stroke. So half revolution of crankshaft is happening during the one stroke, means there will be the 2 revolution will be occur for performing the fourth stroke. So here during first stroke we are achieving the suction process. During the second stroke we are achieving the compression process and combustion process. During the third stroke we are getting the expansion stroke, or it is the power stroke, and last stroke is the exhaust stroke. During that we are achieving the exhaust stroke. So same thing is given over here. This is the suction stroke. So here we have opened the inlet valve. So as we are opening the inlet valve and piston is moving from TDC to the BDC, so there will be suction will be created, and inlet to the intake system or through the inlet manifold, fuel air mixture will come inside the cylinder. So during this valve will remain open. So this is the compression stroke. So piston is moving from bottom dead center to the top dead center, and both valves are in closed position, and due to the movement of the piston from BDC to the TDC, the suction charge will compress from total cylinder volume to the clearance volume, and at the end of compression there will be the spark will produced by the spark plug, and due to that spark fuel air mixture will get burned, and due to the burning of the fuel air mixture there will be the heat liberation will be occur, and due to the heat liberation pressure will be acted over the cylinder piston, and piston will move and it will produce the power in the form of shaft power. So this is the power stroke. So this is the power stroke we have already discussed over there. Then this is the exhaust stroke. So just during the expansion stroke, this piston is come at the bottom dead center. When it is coming at the bottom dead center, this exhaust valve will open instantaneously, and instantaneously the heat inside the cylinder will get rejected to the atmosphere at constant volume, remaining the piston at bottom dead center. After that this piston will move from BDC to the TDC, expelling out the byproduct of combustion, and once it is coming at the top dead center,